So we learned in the last video that a triple integral can be processed any one of three ways and they'll all get you the same answer. So why would you pick one way or another over another? And the answer is just convenience. You know, we just do whichever is easier for us. Usually if we have to integrate something by hand, we'll go with whatever's easy to integrate by hand first, right? And keep in mind this is all the rectangular coordinate system, but other coordinate systems are coming. Dun dun dun. All right, so we're going to use a triple integral to find the volume bounded by z equals the square root of y, z equals y, x equals 0, and x equals 5. Well, I graphed that in Maple. So I have it right here. So this is 0 square root of y and y, right? So there it looks like that. It looks like an airplane wing. Right? So the plane that's coming in an angle right there, that's y, z equals y. And then this kind of curved piece right here, that's like the wing of the plane, is the square root of y. And it goes from 0 to 5 for your x and 0 to 1 for your y, and then I just graphed it. And then this down here is the other gray part down here is the shadow cast by that, well, the intersection of those two functions. All right, so, and believe it or not, one of those is actually pink. It just doesn't look pink, but it is. It's not gray. It's pink. Maybe I should make it red or something to make it more obvious. There, I made it blue. So there are your two functions, and then the gray part down there is the shadow. Okay, so how am I going to do this? Well, first thing I'm going to do is kind of draw a sketch of that. It doesn't have to be a great sketch, but it's kind of an airplane wing kind of a shape, and you've got it kind of coming out. And you're building your volume based on stacking the columns from this floor of xy on the xy axis, or excuse me, on the xy plane, which you can see kind of right here. You're coming from this region up. Now, how do I find that region? I mean, how did I know that y was going to go from 0 to 1? Well, you can set the two equations equal to each other and solve it, right? But you can also just kind of look, right? So if x is going to go from 0 to 5, y is going to go from 0 to 1 because you set the two equations equal to each other and solve, right? So the square root of y is equal to y when y is equal to 1. And there you have it. Right? So that's where the 1 comes from, that's where the 5 comes from, which is nice because that means this region's kind of easy. It's actually a rectangle. Unlike this example here where our regions were triangles and that made it so we had to have a function on the middle term with that blue one right there with the negative 4/3. This isn't going to be as difficult as that because our region is a rectangle. Okay, so if we want to find volume, we're going to be integrating 1. So when you see this volume right here, that means that you know your function is 1 for your triple integral. So we're going to take the function with 1, and let's see if this part makes sense. So I'm going to do z first because z is where I have my two functions. And I have my lower function, which is y, and then my higher function, which is the square root of y. Right? So I go from lower to upper. So you might want to label those. Lower z is y, upper z is the square root of y. 1 is, of course, because it's volume. And then we're doing z first. And then x and y, it's kind of 6 in one, half dozen in the other. It doesn't really matter which way you go because everything there is constants. So if you wanted to reverse them and do x next and then y, then so be it. All right, so when I do this integral, let's see here. Oh, I don't actually plot it. I didn't actually do it in Maple, sorry. Let me see if I just did it. Yeah. So the integral of 1 is z. So I'm going to take z from y to square root of y. So that gives me square root of y minus y. And you'll notice there's no x in any of this. If there's no x, then if I integrate with respect to x, it would just give me an x out in front, and that would be 5. So you can see I used that trick that we've already run into several times where I cross off the integral with respect to x because there is no x term in this function at all. Right? So I did that. And then put a 5 out in front because 5 take away 0 is 5. Right? We've used that trick before and we'll use it again. So why didn't I do that for the y's? You're looking up at the original function, you're thinking, well, there's no y's in that. Oh, but there's y's in the limits of integration. So if you look at the z limits of integration, there's y's there. So I can't cross off the y's. You actually could have crossed off the 5 for the x's right away at the first step if you wanted, because there is no x in this function anywhere, nor will there be. All right, so once I got that 5 out there, that makes this problem a lot easier, because then I'm just integrating square root of y minus y with respect to y. And of course the square root of y is y to the 1/2. So I add a 1 to the power. That gives me y to the 3/2 times 2/3. And then minus, and then you add 1 to the power of y here. So it's y squared and multiplied by 1/2. And you take that from 0 to 1. And you stick all this into a calculator or computer, and you'll get 5 times 1/6. The green part there is equal to 1/6, so you have an answer of 5/6. And just in case you don't believe me, I actually did find it in Maple. I showed a different way to plot the same surface. So there you go. So one, I used plot 3D right here, which I kind of prefer if I can use it. And then the other one I used implicit plot 3D, which is fine, but it's not my favorite. And then I found the integral, you can see, with 1. So y to the square root of y from 0 to 1 for y, 0 to 5 for x. There you go. That gave the fraction. If you want a numeric answer, just type comma numeric. And it doesn't really matter which direction we go. And in case you didn't believe me about the 5 coming out, I actually showed that it works right here. So I did 5 square root of y minus y, 5 times the square root of y minus y, from 0 to 1, which was after I had gotten rid of that 5. And I proved that it's the same thing. It's 5/6, the same thing as what we originally were given. So it all works out. 5/6.